All right, so we're talking about 7.2, verifying solutions for differential equations. The AP exam is going to be just for your response questions this year, so you're not necessarily going to see questions like this in this exact format, but we could see a question where, they're asking you to prove if something is a solution to a differential equation or something like that. So we still need to know how to do it. So here they've given us our y, and they've said that y is equal to e to the 3x minus 5x plus 7. And we have these different answer choices. So what we're going to want to do is we want to find out what y prime and y double prime are so that we can plug these different things into this equation and see if we get 0. So y prime, if we take the derivative of e to the 3x, when we chain rule it, we're going to have to chain rule and get this 3. So it's really going to be e to the 3x times 3. And then minus 5, and then the 7 is going to go to 0. Y double prime, same situation here. We're going to have 3 e to the 3x, and then we're going to have to multiply by 3, chain rule that 3. So we're going to end up with 9e to the 3x, and then the negative 5 is going to go to 0. So once we have that, what we can do is we're going to use these things here to plug into our different equations, see which one gets us to 0. So we have 9e to the 3x, that'll go in for the y double prime. Then we'll have minus 3 times y prime. Then we'll simplify, so negative 3 times 3 is going to be minus 9e to the 3x. Negative 3 times negative 5 is going to be plus 15. Minus 15 equals 0. So then we have a bunch of canceling that happens, so we end up with 0 equals 0. So in this particular example, it just happened that the first answer checked out, so that's lucky for us. And so A would be the answer there. Okay, next one here. If dy dx equals y secant squared x and y equals 5 when x equals 0, then what is y? So first thing that I did on this was plugged in this point. So we know that we have this point 0, 5. We can plug in our x values and see if we get the correct y value. So e to the tangent of 0 is 0. Anything to the 0 power is going to be 1. So 1 plus 4 is 5. So that one checks out. This happens to be the same setup, except now we're adding 5 instead of adding 4. So it's really just going to increase 1 from this answer here. So we're going to get 6 on that answer. So we can mark out B for that one. Then we have 5 times e to the tangent of 0. So that's 5 times e to the 0, which is 5 times 1, which is 5. So that checks out. Tangent of 0 plus 5 is 0 plus 5. So that works. Then we have tangent of 0 plus 5e to the 0. So that's 0 plus 5 times 1, which is also 5. So B is really the only one that we marked out, plugging in the points. Now what we're going to go to is, what we're trying to look for is okay, which of these answer choices, if that was y, and then I took the derivative, so I did dy dx, am I going to get this pattern where my original function that I started with is multiplied by secant squared x? So we're going to just test each of these. So we have e to the tangent x plus 4, and we'll say y equals that. So when we do dy dx, e to the tangent x, and then we have to chain rule tangent x, which is secant squared. And then plus 4 is going to go to 0, so we have that our y value, so this y value right here would need to have been e to the tangent x. That is not what we started with, so A is not going to work out. So then we'll go to C. We already marked out B. So we have y equals 5e to the tangent x. When we do dy dx, we're going to get 5e to the tangent x times secant squared x. And what we're looking for is the other pieces that aren't secant squared x. We want those to be our original y. And so when we look at this matches up with this piece here. So C is going to end up being our answer. And we could continue on and check those other two problems to make sure if we wanted to. We're going to skip over to number 3. Okay, so we have number 3. A curve has a slope 2x plus 3 at each point xy on the curve. Which of the following is an equation for this curve if it passes through the point 1, 2? So if I was starting this one, I would start off with the point. I plug in my x value, see if I get that corresponding y value. 5 times 1 is 5. 5 minus 3 is 2, so that checks out. Then we have 1 squared plus 1. 1 squared is 1, plus 1 is 2, so that also checks out. One squared is 1 plus 3, which would be 4, so that does not work. So we can mark off C there. 1 squared plus 3 times 1 minus 2. So 1 squared is 1. 3 times 1 is 3, so that's 1 plus 3 is 4. 4 minus 2 is still 2. And then this last one, we have 1 squared is 1, so this part's going to be 2, plus 3 is 5, 5 minus 3 is going to be 2. So we were able to eliminate C. And then the next part that we could do is we're saying that a curve has a slope of 2x plus 3. So what we want to do is we want to find the slope at each one of these points here, at this specific point. So we're going to find the derivative of each one of these. So we have dy dx on A is going to be 5. B dy dx is going to be 2x plus 0, so just 2x. So that doesn't work. C is gone, so D is going to be 2x plus 3. And E is 4x plus 3. So 2x plus 3 is the answer we're looking for, so that would be D here. Okay, and then we're also going to do number 4. For what value of k, if any, will y equal k sine 5x plus 2 cosine 4x be a solution to the differential equation y double prime plus 16y equals negative 27 sine 5x? So what we're going to do here is they gave us y. We're going to find y prime and y double prime. We're going to plug those in, and we are going to solve for k. So here is our y. So when we're taking the derivative here, we're going to have k. The derivative of sine 5x is going to be cosine 5x. But then you're also going to have to chain rule the 5. So we can say 5k cosine 5x plus, and then it's 2 times cosine of 4x. The derivative of cosine is going to be negative sine, and then we're going to have to chain rule the 4. So we're going to end up with this negative 4 that's going to get multiplied. So we're going to actually say negative 8 sine 4x. And doing plus minus doesn't really make sense. Then we'll derive again. So 5k, k is just a constant, it's some number. So we can do the derivative of cosine 5x. That's going to be negative sine 5x. And then we're going to have to chain rule the 5. So we're going to have this negative 5 that's going to get multiplied here. And you can write out every step. Okay, and then we come over here. The derivative of sine 4x is going to be cosine 4x times 4. So 8 times 4 is going to be 32 cosine of 4x. Okay, and so that is going to help us plug in. So we have these two things that we're going to plug into this equation right here. So y double prime is negative 25k sine of 5x minus 32 cosine of 4x. And then we're going to do plus 16y. Y is this deal right here. And then it's going to equal negative 27 sine of 5x. All right, so then if we distribute this 16 here, we're going to end up with negative 25k sine of 5x minus 32 cosine of 4x plus 16k sine of 5x plus 32 cosine of 4x. What we can see here is we can combine some like terms. So we have this negative 32 cosine 4x and a positive 32 cosine 4x. Those are going to cancel each other. And then we can combine these two deals here because they have the same kind of back end portion. So negative 25 plus 16 is going to be negative 9. And that's going to equal negative 27 sine of 5x. We're trying to solve for k. So we're going to divide both sides by the portion that we want to move. That cancels and that cancels. And we're going to be left with k equals negative 27 divided by negative 9 is 3. And then these sine 5x's cancel. So all of that to get k equals 3. You'll do the rest on your own, and if you have any questions, let me know.